Gemini. Tell me 10 facts about fusion power. Draft modified by user. Star power. Fusion is the same process that powers the sun and stars. By harnessing this reaction here on Earth, we could have a near unlimited energy source. Fusion is the process of combining atomic nuclei, releasing a tremendous amount of energy in the process. It's the reason the sun shines so brightly and provides us with light and warmth. Scientists are working on replicating this process in fusion reactors to generate clean and sustainable energy for our planet. Clean energy. A major benefit of fusion is its minimal environmental impact. Unlike fossil fuels, fusion doesn't create greenhouse gases and produces little radioactive waste. Fossil fuels like coal, oil, and natural gas release harmful greenhouse gases like carbon dioxide when burned, contributing to climate change. Fusion reactors, on the other hand, would be a much cleaner alternative. They primarily produce helium, a harmless gas, as a byproduct, and the small amount of radioactive waste generated by fusion decays in a matter of decades, unlike the long-lived radioactive waste from nuclear fission reactors. Hot stuff. To make fusion happen on Earth, we need incredibly high temperatures, reaching up to 200 million degrees Celsius, hotter than the sun's core. At these scorching temperatures, atoms are broken apart into a state of matter called plasma, where electrons are stripped away from their nuclei. This superheated soup of charged particles is what needs to be contained and controlled to achieve fusion. Taming plasma. Fusion reactions rely on a state of matter called plasma, where atoms are stripped of their electrons. Controlling this superheated plasma is a major challenge in creating a fusion reactor. Creating and confining plasma on Earth at these extreme temperatures is one of the biggest hurdles in developing a commercially viable fusion reactor. Powerful magnetic fields are used to contain the plasma, but maintaining its stability for long enough to produce sustained fusion is a complex task. Fuel for the future. The fuel for fusion is readily available. Deuterium is extracted from seawater, and tritium can be bred from lithium, another abundant resource. Deuterium is a naturally occurring isotope of hydrogen found in vast quantities in seawater. Tritium, another key ingredient, is not readily available in nature but can be bred from lithium, another plentiful element. This means the fuel source for fusion is essentially limitless, unlike the finite reserves of fossil fuels. Always on. Unlike solar or wind power, fusion reactors wouldn't rely on weather conditions. They could theoretically produce energy 24/7. Solar and wind power are excellent renewable energy sources, but they are variable depending on the weather conditions. Fusion reactors, on the other hand, would be a constant and reliable source of energy production, operating continuously day and night. Safer than fission. Compared to conventional nuclear reactors that use fission, fusion has a much lower risk of meltdowns, and the radioactive waste produced is short-lived. Nuclear fission reactors generate energy by splitting apart heavy atoms. This process carries the risk of meltdowns, which can release dangerous radioactive materials into the environment. Fusion reactors, on the other hand, are inherently safer. They cannot undergo runaway chain reactions like fission reactors, and the radioactive waste they produce is short-lived, decaying in decades rather than thousands of years. Breakthrough potential. Research into fusion power has led to many scientific and engineering advancements that benefit other fields as well. The pursuit of fusion energy has driven innovation in various scientific and engineering disciplines. Powerful magnets, advanced materials science, and plasma physics research conducted for fusion research have led to significant advancements in other areas, such as medical imaging technology and superconductor development. The race is on. Scientists around the world are working on making fusion a reality. While there are still hurdles to overcome, progress is being made. Fusion research is a global endeavor, with scientists from many countries collaborating on achieving this breakthrough in energy production. International projects like ITER, International Thermonuclear Experimental Reactor, are bringing researchers together to develop the technology needed for a commercially viable fusion reactor. A brighter future. Successful fusion power could revolutionize our energy production, offering a clean, sustainable solution for the future. If we can successfully harness fusion energy, it has the potential to transform our energy landscape. It would provide us with a clean, sustainable, and virtually limitless source of power, helping us combat climate change and ensure a secure energy future for generations to come.